Now on to the fourth part of the city building series. Now in this fourth part, we will focus most of our time on the various external graphs and blueprints that can work in conjunction with the main city graph. First, let's start with the construction spline we saw in the previous video. Now first off, let's start with something that's a little new. I made this graph around the time grammar was first introduced. Although it wasn't used as much as I thought it would, it is still essential for the first part of this graph. First, we get the bridge spline data assets. This is where we store the meshes used in the bridge. I don't think I need the blueprint just yet though. This is where you would put the spline middle segments, the spline end segments, and the various bridge structure parts. For now though, we only need the middle segments and keep only the mesh. We now add the spline module as an attribute, which is a created PCG parameter that is a PCG subdivision submodule type. The values here aren't important besides the symbol, which is middle. Size will be overwritten later, so just give it a placeholder value. Next, we get the bounds from mesh and copy the local size x to the size attribute. The next three nodes are unused, so you don't have to worry about those. What we do need to do next is convert the points to attribute sets, and keep only the size for the middle segment size. Down below, we now use the grammar for the subdivide spline and the match and set attribute. Now besides the grammar, I do think a large part of this can be breezed over since it's something we've seen plenty of times before. We start by sampling the spline using the segment size, then we filter out the points that go over the water when landscape projecting and create a spline. Now this partition node here I think is a leftover remnant that we don't need, so I'm just going to go ahead and delete that. Alright, next we're going to create a curve for the spline when going over water. First we have a distance node while targeting the water points. We then save the index to a new attribute before splitting the points via their density. The points that got filtered out will now be sorted by density, and then also partitioned by density. We also have a blueprint variable called curve over water that is a vector we can split for more control. That curve I currently have by default set to 700. Now inside the subgraph itself, it takes the density, multiplies it by -1. That then gets multiplied by the incoming variable and then plugged into the offset of the transform points. And we also want to save out the first loop as its own output. This is because the bridge overall as a whole will always be off by that first loop. So once outside the graph, you have another transform points and the offset will be the negative of that saved output. Alright, next we re-merge the points and sort by saved index. That completed spline then goes on to the prepared spline mesh spawner. Alright, now we need to start preparing for the columns. We do a little bit of logic here to check if there's a landscape. If not, it can instead do a ray hit query to project to whatever you're using as a ground mesh. We also move the points up a little bit with a transform node, but not strictly necessary. Alright, and then next is a part we've already seen in the previous video, a subgraph that produces those columns. But the part that will matter most is the section over here that outputs to other graphs. Here is where you add the attributes and make it possible to filter out the correct data. So make sure to give everything a consistent name. Down below we also have the add meshes along the spline section. Also a piece from a previous video, so let's move on to the next part up here. Now, one of the issues of using the spline mesh spawner is that the entire spline will only ever use one singular mesh. So if we want a different mesh for the end or start of the spline, we have to do this. First we get the start and end segments of the spline. Then we filter out the point before that endpoint. And then we lerp from the position of these points to create a new spline that follows the curve of the existing spline. We can now select from our list of end segments using a variable parameter and spawn a spline mesh that follows the curve of the rest of the spline road. You can ignore that portion up above. I was experimenting with closed loop splines. Now to actually see the effects of our work, I'm going to change the mesh used for those endpoint segments. Since by default I think I just used the regular street mesh. Alright, there we go. It does seem to be a little stretched along the length though. Looks like I forgot to adjust the parameter I used for the lerp. Now on to the next set of graphs. Now back when PCG was first introduced, the first video I made was how to make procedural cities and towns in a PCG video. The techniques I used then are a little outdated now, but after revisiting the graphs I felt like the form still had potential. Hence, we now have PCG Town Graph version 2. Now first it starts by grabbing all the manually placed splines in the scene. You might have to change to must overlap self in case there is more than one town in a single level. So the first thing we do is we loop through the splines to find intersects between them and use those intersects to splice them up. And the subgraph doing that is of course the same subgraph we made in the earlier video. Following that, we use one of our existing subgraphs to once again spline meshes along the spline. Now up above, we're going to spawn our buildings. First, we sample the spline with distance between buildings being a variable parameter. We create two sets of those points on either side of the road and pass the center of the splines as the difference for the ending subgraph. We do a few more things if there's a landscape. We get a normal to density and save the land normal. Then we reset the density back to 1 and set the pitch and roll to 0. We then use the select points and match and set the PCG building assemblies. From here we need to copy the index and save it as the building number. Next, partition by the assigned assembly and do the PCG data loop to get the assembly meshes. We now need to partition by the building number since the meshes at the moment are all together. We then have a building rotation loop that checks for any overlaps and does some random rotations. Although the random rotations aren't really used in this particular instance. Alright, so the first thing the graph does is it combines the points since the building meshes need to be treated as a single whole entity for the purpose of this graph. Branch 4 if you want a completely random rotation or if you want to snap by an amount of degrees. Next, the building is moved slightly back by half the Y of the building. This is to place the building door at the point where the center point is, since this is a more accurate and predictable way to spawn buildings by their front door than by their center point. From there, difference from both any overlaps and plugged-in exclusions like the center of the spline. At the end, we merge the current building with the existing building feedback into the new feedback for the next loop. And we also have a branch here to fix a PCG error that occurs when a loop happens without a point going out. This is something that I've realized about PCG is that in many cases it's better to have no output than an empty output. For me, this has been a source of many frustrations and many bugs. Anyway, that exit outs into the main graph and feeds into the assembly building loop graph. That's one more graph that's already been covered, so that makes videos from here on quicker and quicker. It's still mostly the same as it was in the building assembly video, except the start of the graph is now cleaned up and a little bit neater. Alright, and then down below in the main graph. Now down below in the graph, we have a method to randomly spawn assembly buildings away from the main roads. Again, nothing new here. The only thing different is at the very end, we will save the door points to a reroute node. This will be essential for creating these sort of stone pathways. Now down below that, we create a scatter grid. We'll assign the scatter meshes to the points and sort them by weight. We then partition by the meshes and feed into a new subgraph called PCG Town Scatter. This graph basically acts as a randomizer for the points. First, it applies the bound of the mesh. It does a per mesh transform and checks for the landscape. Now before we continue, let me open the data asset so you know where these settings are coming from. Alright, we check if the mesh accepts exclusions from others and have the select node choose from taking points from the difference node or the points directly. We then difference from the non-optional things like the core city and the always exclude input. We then distance to get how far from the city and town the scatter will appear. We add a little noise to give it a little more random. Then we filter. We then add a select points and then an optional self prune. We then check if it outputs exclusions to others and merge that with the previous feedback for the next loop. Now onto something a little more new. First, we take the grid we had before and difference the buildings. We're going to need the building doors from the assemblies. These are going to be the starting points. We then merge those doors with the road spline end and start indexes, and those will serve as the possible endpoints. We then have some parameters for controlling the pathfinding, and now onto our new subgraph. Now inside the pathfinding node, we set the start and go location as an input, and the cost function to a fitness score and the cost to density. The start can be plugged right in from our start points. And now we need to sort through our endpoints. First, a difference since we don't want paths to end at their own start point. Next, a distance node so we can sort them by their distance from the start point. Next, the attribute filter to select the closest point. And then we also have a select node if you want the selection to be completely random with no regard for distance. This then becomes the goal point, and the point then gets turned into a feedback for the next loop so it won't be chosen again. This prevents the same endpoint from being chosen repeatedly and other points from being ignored. Once that's done, we exit back into the main graph and prepare the points for the spawn along the spline subgraph spawner. Now, on to actually using these. The main blueprint is what does most of the work, so that is what you add to the level first. You next start by adding the town road blueprint splines. The blueprint itself doesn't actually do anything or have anything attached except the spline. Its only purpose is to be a pre-tagged spline that you can drag and drop and reuse quickly. Now, it is important to note that the two graph groups don't work together yet, which is why I've made sure to separate them into different folders and categories like so. Now that finishes up most of what I have considered finished up to this point. There are a few things that still require a little more work, like the circular graph over here. It's almost ready, but still has some rough edges that need to be smoothed out. Now in the next video, we'll be focused on using the graph instead of just making it. I think it will make for a demonstration on how to put it all together. So up next, I'll be showing you how to use the city graph to make this urban residential setting. That's it for now, thanks for watching.